This video is going to be about adding and subtracting radical expressions. It's very similar to combining like terms, as you've probably learned previously. An example would be 3x plus 4x are like terms, and so we are able to add them together, which means the coefficient is what officially changes because you're adding the 3 and the 4 to get 7. And the reason we are adding them together is because they both have the same exact variable with the same exact exponent. That's what makes them like terms. That's what makes us able to actually add them and subtract them. So I'll just give you one more example. I'll do 2x squared minus 5x squared. Again, these are like terms because they both have the x squared component, but essentially what that means is we are combining the coefficients, which will leave us with a negative 3x squared. So these are like terms. So as we start to talk about adding and subtracting radical expressions, I want you to kind of think of it as adding and subtracting like radicals. Well, what makes a like radical? Let's go over some examples. So let's say we have 5 square root of 3 plus 2 square root of 3. So now it's like the 5 and the 2 are the coefficients, right? And the square root of 3 is the variable slash exponent. It's the part that matches. It's the part that makes them like radicals. Now, since they do have the same exact radical, that means that I can take my coefficients 5 and 2 and get 7 square root of 3. Notice that the square root of 3 did not change. That's what made them match, and that's what stayed the same, just like when we were adding and subtracting just regular like terms. Let's go over another example. I have 2 square root of 5 plus 7 square root of 6. Now in this case, you can see that the radicals do not match, so I cannot combine these to get 9 square root anything. But I do want to check before I decide that I'm done if I can simplify anything. And I can see that the square root of 5 cannot be simplified any further without a calculator. And although 6 does have the factors 2 and 3, since I can't take the square root of 2 or 3, there's no sense in me breaking that number down anymore. I can't simplify this any more than it is without a calculator. So now let's go into some additional examples of adding and subtracting radicals. I have 3 square root of 2 plus 5 square root of 2, which again, they both have the square root of 2. So yes, I can add my 3 and my 5 to get 8 square root of 2. I'm just going to keep going with some more examples. 2 square root of 3 plus 4 square root of 5 minus 6 square root of 3 plus square root of 5. So here we just have more than one term. So I want to look for ones that match. I can see 2 square root of 3 and minus 6 square root of 3 are like radicals, so I would actually get a negative 4 square root of 3. And then I can also see I have 4 square root of 5 and just a regular square root of 5, which technically there's like a 1, so I'm going to have a positive 5 square root of 5. And here, these are not like radicals there, so I cannot simplify them anymore. I would be done right there. Again, let's just keep working a few more examples. I have 2 square root of x plus 7 square root of x. And yes, I know in the previous examples there was always numbers underneath our radical symbol, but that's not the important part. The important part is that they match, and these do match, so I am going to get a 9 square root of x. And I'll just keep going. 7 square root of 3x plus 2 square root of 3x. Again, they both have square root of 3x, so I'm going to get 9 square root of 3x. Let's see here, another example. I have 7 square root ab plus 2 square root a squared b minus 3 square root ab. So I can see pretty quickly that I have some like radicals here. 7 and negative 3, they both have a square root of ab. These will combine to give me 4 square root of ab. Now this one, I can see that there's something here that I can simplify. The square root of a squared is a, which means it's going to get kicked out. So I'm going to have a 2a in the front. Square root of b. These are not like radicals, so I would go ahead and leave that alone, just as it is. And just one more example. We have 5 plus 3 square root of x plus 4x. So here I have a constant, which is just a plain old number, right? I have a radical term here, and then I just have our typical terms that you guys are used to seeing. None of these match. None of these are like terms. I can't simplify them any further. Now, something you want to be mindful of is sometimes we may need to actually simplify our radicals before we can determine whether we can add or subtract them. So, for example, I wrote that down. For example, in this problem, square root of 45 minus the square root of 27. As is, no, I cannot add and subtract them. But if I'm really paying attention, I can see that the square root of 45 can be broken down into two factors, one which is perfect and one which is not. Bring my sign down. As well as 27 can also be broken down into two factors. Okay? And then I can see why I can say the square root of 9 is 3 on both of these terms. So I'm left with 3 square root of 5 minus 3 square root of 3. Now in this case, I simplified those radical terms and I still did not get like radicals. So that's as far as I could go. Let's see if there's another one here. Okay. So what about 5 square root of 8 plus 2 square root of 18. Okay, here again, as is, I cannot add them, but again I can see that 8 can be broken down in 4 times 2. And again, if you're going to break a number down, it makes sense that it actually would be at least one of the factors has to be perfect. Okay, so in this first one, the square root of 4 is 2. It gets kicked out, so I have 10 square root of 2. Square root of 9 is 3. So I have 6 square root of 2. So you can see here that after simplifying those radicals individually, I do have like radicals square root of 2. So I'm going to end up with 16 square root of 2. Last but not least, we'll just do one more example. We don't want the video to be too long. I have 2 square root of 24x squared minus x square root of 54. Again, as is, they're not like radicals, but I definitely can break these down a little bit more. So I'm going to have 2 square root of 4 times 6 times x squared minus x square root of 9 times 6. So I can see that the square root of 4 is 2. Square root of x squared is x. So I'm going to get a 4x square root of 6. And then here, the square root of 9 is 3. So I'm going to end up with minus 3x square root of 6. Now, at first glance, they do have like radicals, right? But I want you to kind of pay attention to the fact that the coefficient also needs to match. So I have 4x minus 3x, which is a good thing. They're like terms. So I'm actually going to have just a 1x or an x square root of 6. So I could just write it just like this.